In 1996, this machine dominated the American driveway, not because it was practical, but because of how it made you feel. It felt heavy. It felt safe. It promised the rugged capability of a tank and the silent, floating comfort of a luxury sedan. For a few golden years, it was the ultimate status symbol for the suburban family, but that specific blend of grit and comfort came with a hidden cost. The engineering decisions that made it feel so invincible were the same ones that would eventually ruin its reputation. This is the story of the second-generation Ford Explorer. To understand why this machine is still so revered by enthusiasts despite its troubled history, we have to look past the headlines and into the metal itself. The development of this generation began almost immediately after the first one launched. Under the design leadership of Bob Akins in 1992, the team faced a paradoxical mandate. They had to soften the truck without losing the rugged identity that sold millions of units. The engineering challenge was immense. They had to take a shape described as relentlessly rectilinear and make it slip through the air. The goal was to achieve a drag coefficient of 0.43. While that number might seem brick-like compared to a modern vehicle, it represented a monumental shift for 1995. To achieve this, the designers removed the chrome underbite bumpers of the first generation. They integrated the bumpers directly into the fascia and smoothed the roofline transition. This was not merely for aesthetics, it was an acoustic necessity. To create a quiet cabin, the wind had to be managed, not just blocked. This level of intentionality extended to the manufacturing floor. The ambition for the platform, known internally as the UN105, was global dominance. Unlike the Bronco 2, which was a niche product, this vehicle was designed to be exported. Production scaled massively across facilities in Louisville, St. Louis, and Valencia, Venezuela. The logistical scale of this operation required a chassis that was modular enough to accept multiple powertrains, while maintaining a consistent build quality. This period marked the height of the Job One quality initiatives at Ford. The tactile feel of a switch and the consistency of a panel gap were scrutinized more heavily than in the utilitarian 1980s. The goal was to create a sense of heft and permanence. When a driver reached for a door handle, it needed to feel substantial. When a button was pressed, it required a deliberate action. This was the definition of quality in the mid-90s. It was about material substance rather than digital features. The engineers prioritized tactile weight and mechanical durability. They wanted the vehicle to challenge the build quality of Japanese imports. This required massive investment in tooling. They ensured that the UN105 would not just be a truck, but a flagship for the brand. The result was a vehicle that felt carved from a single block of material. However, to make a truck truly acceptable to the suburban aristocracy, the changes had to go deeper than just the sheet metal. The real revolution was happening underneath the frame, where the old agricultural roots were being severed to make way for something entirely new. Perhaps the most significant engineering decision made during the development phase was the abandonment of the twin I-beam front suspension. This system, and its four-wheel drive counterpart known as the twin traction beam, had been a hallmark of Ford trucks for decades. It was legendary for its durability and wheel articulation, but it was despised for its handling characteristics. The design caused significant camber changes during suspension travel, leading to vague on-center steering feel and rapid, uneven tire wear. For the new platform, engineers argued that a luxury sport utility vehicle could not require constant steering corrections on the highway. They successfully lobbied for the adoption of a short long-arm independent front suspension with torsion bars. The shift to the short long-arm system was transformative. By using unequal length control arms, engineers could optimize the camber curve, keeping the tire contact patch flat against the road during cornering. This decoupled the movement of the left and right wheels, eliminating the shimmy associated with the solid beam connection of the past. It allowed for a more precise rack and pinion steering system to replace the old recirculating ball setup. This offered the driver feedback that mimicked a car rather than a tractor. While this sacrificed some of the raw durability of the old truck beams, the trade-off was deemed necessary to capture the suburban buyer who demanded a relaxed driving experience. The pursuit of isolation extended deep into the chassis structure with the introduction of quiet steel technology. In the mid-90s, noise, vibration, and harshness became the new battleground for automotive supremacy. Ford partnered with Material Sciences Corporation to implement a laminated steel technology in the firewall and dashboard panel construction. Quiet steel is a composite consisting of two metal skins sandwiched around a 25-micron weldable viscoelastic polymer core. The genius of this material lies in constrained layer damping. When the engine vibrates or the road induces a frequency into the firewall, the steel skins attempt to move. This movement creates shear strain in the polymer core. The viscoelastic polymer resists this shear, converting the mechanical vibrational energy into low-level heat, which is then dissipated. This was not a band-aid solution like adding heavy rubber mats or jute padding. This was designing in the quiet at the molecular level of the chassis. It represents a stark contrast to the modern approach. Today, manufacturers often rely on active noise cancellation software to play anti-frequencies through the speakers to mask structural deficiencies. In 1995, the luxury was achieved through physical substance and expensive materials rather than digital simulation. It created a cabin that felt sealed off from the outside world. This pursuit of isolation, of creating a perfect bubble, would eventually become the vehicle's greatest vulnerability. But that story comes later. This sense of sealing was reinforced by the calibrated door thunk, which became a primary metric of quality. Engineers heavily scrutinized the striker alignment and door seal density to produce a low-frequency, heavy sound upon closing. It was designed to feel like closing a bank vault. This sound was a subconscious signal of safety that resonated deeply with parents. It stood in opposition to the tinny hollow clack of competitors. The exterior door handles were heavy, spring-loaded triggers that required a deliberate muscular actuation. Every interaction with the vehicle was tuned to convey a sense of weight, reinforcing the idea that the occupants were protected by a substantial machine. For the top-tier Eddie Bauer and limited trims, Ford offered an automatic ride control air suspension. Using height sensors and an onboard compressor, the system would self-level the rear end when towing heavy loads. Crucially, it would also lower the vehicle at highway speeds to reduce drag and improve stability. It was peak over-engineering. While it provided a magic carpet ride when new, the air bladders were prone to dry rot after 5 or 7 years. This led to the sagging rear end often seen on neglected examples today. It marked a level of complexity that signaled the end of the simple repair era. While the chassis was designed for silence, the powertrain was a battle between old-school grit and modern complexity. The chassis may have been designed for silence, but the powertrain options represented a battle between old-school grit and modern complexity. The hierarchy of engines available during this generation tells the story of a company in transition. At the bottom of the ladder sat the 4-liter Cologne V8. This engine came in 2 very different flavors, and the distinction between them defined the ownership experience. The base model utilized an overhead valve configuration. It was a cast iron lump that traced its lineage back to the 1960s. Producing roughly 160 horsepower, it was known for being agricultural. It vibrated at idle and ran out of breath at highway speeds, but it was virtually indestructible. It was a tractor engine placed in a luxury wagon. However, to compete with the rising horsepower figures of the Jeep Grand Cherokee, Ford introduced a more sophisticated variant in 1997. This was the single overhead cam version of the V6. It retained the displacement but added high-flow aluminum heads, boosting output to over 200 horsepower. On paper, it was the superior engine. In reality, it introduced a fatal flaw known as the death rattle. To fit the overhead cams into an engine bay designed for push rods, engineers placed the timing chain for the passenger bank at the rear of the engine. When the plastic chain guides inevitably failed, servicing them required removing the entire engine from the vehicle. It was a level of complexity that signaled the creeping end of the simple repair era. For the true connoisseur of this generation, there was only one correct choice. In 1996, Ford introduced the 5-liter V8 option. This was not the modern overhead cam engine found in the Crown Victoria. This was the legendary Windsor pushrod V8, the same architecture that had powered the Ford Mustang for decades. The inclusion of the Windsor in a mid-size sport utility vehicle was a swan song for the American small block. It turned the family hauler into a hot rod in disguise. It provided a torque-rich, effortless driving experience that smaller engines could not replicate. The V8 models are fascinating because they contain a level of factory hot rodding that is unheard of today. The early models utilized GT 40-cylinder heads. These were essentially the same high-performance heads used on the 1993 Mustang Cobra. For collectors, these are the holy grail because they allow for the direct bolt-on of standard Mustang exhaust headers. However, in late 1997, Ford switched these to the GT40P heads to improve emissions. While these heads actually flowed better, they relocated the spark plug tip closer to the center of the combustion chamber. This new angle meant that standard headers would interfere with the spark plug boots, melting the wires. It is a nuance that creates a sharp divide in the enthusiast community. The intentionality of the V8 went beyond just the cylinder heads. The engine utilized a cast aluminum intake manifold that is widely considered one of the best factory designs Ford ever produced. It flowed nearly identical numbers to the high-performance Cobra intake. Ford engineers did not simply detune a truck engine. They utilized parts bin components from their racing division to ensure the 4,500-pound vehicle could merge onto the freeway with authority. The Windsor V8 would become so coveted that it would change the fate of thousands of explorers in ways Ford never anticipated. This mechanical confidence was matched by the drivetrain sophistication. The difference between the V6 and V8 models extended to how they delivered power to the ground. The V6 models used the control track system with a Borg-Warner 4405 transfer case. This system was managed by a dial on the dashboard, allowing the driver to switch between two-wheel drive, automatic four-wheel drive, and low range. It was a system designed for the weekend warrior who might actually go off-road. The V8 models abandoned this pretension entirely. They used the Borg-Warner 4404 transfer case, which offered no buttons, no levers, and no low range. It was a full-time all-wheel drive system that used a viscous coupling. Inside the case, plates spun in a bath of silicone fluid. When the rear wheels slipped, the difference in speed would heat the fluid, causing it to thicken and transfer torques to the front wheels instantly. It was seamless and fluid, eliminating the binding sensation of mechanical systems. It was a set-it-and-forget-it luxury experience designed for the driver who simply wanted to arrive safely, regardless of the weather. This mechanical confidence was matched only by the interior atmosphere, which defined the aesthetic of the 1990s. If the exterior was about softening the truck, the interior was about disguising it entirely. The Eddie Bauer edition, introduced earlier but perfected in this generation, became the definitive visual shorthand for the American upper middle class. The signature two-tone paint schemes, often spruce green or Oxford white paired with Pueblo gold lower cladding, were not just color choices, they were a uniform. But the true transformation happened once the heavy door thunked shut, sealing the occupants inside a capsule of materials that simply do not exist in the modern mass market. The seating surfaces in the high-trim models were upholstered in a thick, deeply grained leather that was perforated for breathability. This was not the thin, polyurethane-coated bonded leather found in today's crossovers, which feels plasticky to the touch. It was robust hide that developed a patina over time rather than cracking. The smell of a well-preserved second-generation Explorer is a distinct olfactory time capsule. It is a mix of tanning chemicals, the off-gassing of the thick vinyl dashboard, and the faint scent of carpet adhesive. For anyone who grew up in this era, that scent is instantly recognizable. The seats themselves were designed as captain's chairs. They were six-way power adjustable and shaped like living room furniture. They offered almost no lateral support, which was a subtle engineering cue. The lack of bolstering discouraged aggressive cornering, subconsciously guiding the driver to adopt the relaxed, commanding cruising style that defined the sport utility vehicle experience. In the limited trim that sat above the Eddie Bauer, the luxury became digital. This model introduced the message center, an early trip computer located in the center console. In an age before high-definition touchscreens, this system used vacuum fluorescent display technology. The distinct bright green luminescence was sharp and instantly readable even in direct sunlight. It did not suffer from the washout common to early liquid crystal displays. It calculated fuel economy, distance to empty, and monitored system health. The way the green characters glowed against the black plastic housing felt like aircraft avionics, providing a sense of technical sophistication that was rare for a domestic truck. The pursuit of isolation extended to the audio experience. The premium sound option was a JBL system that featured a design quirk emblematic of the era's engineering priorities. To ensure the highest possible audio clarity, engineers utilized a distributed architecture. The head unit in the dashboard was merely a controller. The actual tuner and amplification hardware were located in the rear quarter panel. This separation was done to isolate the sensitive tuner electronics from the electrical noise of the dashboard and engine firewall. It was an audiophile-grade decision that made upgrading the stereo 20 years later a nightmare for restorers. But in 1995, it provided exceptional audio clarity. Furthermore, the system featured a 6.5-inch subwoofer. Instead of a bolted-on box that consumed cargo space, the subwoofer was integrated into a dedicated enclosure hidden behind the rear cargo panel, utilizing the body cavity volume for resonance. There was also a hidden layer of interaction that spoke to the relationship between the manufacturer and the owner. The instrument cluster featured a robust onboard diagnostic mode known as the HEC dealer mode. By holding the trip reset button while turning the ignition key, the digital odometer would unlock a hidden menu. Owners could cycle through real-time digital tachometer readings, battery voltage, and coolant temperature in precise degrees Celsius, rather than relying on a dummy gauge. It even displayed specific error codes in hexadecimal format. This feature speaks to a time before the black box era, where the car was a machine to be understood by its owner, not a sealed appliance to be serviced only by authorized dealers. The atmosphere was finalized by the lighting. The cabin was bathed in the warm, organic glow of incandescent bulbs. Footwell lights, glove box lights, and puddle lights under the side mirrors created a welcoming environment. Unlike the harsh, cold flicker of modern LED lighting, the halogen bulbs dimmed softly and created a cozy domestic feeling. It was a space designed to make the driver feel invincible, safe, protected. But in 1999, that illusion would shatter in a way that would change the entire industry. The tragedy of the second-generation Explorer is that its greatest strength, its seductively soft ride, contained the seeds of its eventual destruction. To understand the Firestone crisis, one must look beyond the headlines of the year 2000 and examine the engineering compromises made 5 years earlier. It was not merely a story of a manufacturing defect, though that played a role. It was a story of what happens when a marketing department's desire for isolation collides with the hard realities of physics. The mandate to make a truck feel like a luxury sedan had pushed the platform to its absolute limit, and the weak link in the chain was the only part of the vehicle that touched the ground. To achieve the magic carpet ride quality that defined the era, Ford engineers faced a problem. The suspension, while improved by the short long-arm design, was still stiff enough to transmit road harshness into the cabin. To dampen this, they made a critical decision regarding the tires. The recommended tire pressure for the Explorer was set at just 26 pounds per square inch. For context, most passenger cars of the era ran at 30 to 32 pounds per square inch, and heavy trucks ran much higher. 26 was an unusually low number for a vehicle weighing nearly 4,500 pounds. The logic was simple. A softer tire acts as a secondary shock absorber, soaking up small imperfections in the pavement before they ever reach the suspension components. It made the vehicle feel floaty, compliant, and luxurious. However, the physics of a tire underload are unforgiving. When a tire is underinflated, the sidewall bulges outward where it meets the road. As the wheel rotates, that section of the sidewall flexes and then snaps back into shape. This constant flexing creates friction at the molecular level, a phenomenon known as hysteresis. Friction generates heat. At highway speeds, specifically during the sustained cruising that American families used the Explorer for, the heat buildup within the carcass of the Firestone wilderness. AT tires became critical. The rubber compounds and the steel belts began to lose their cohesion. The adhesive bonds that held the tire together were cooked from the inside out. The failure mode was catastrophic. The tread would separate from the body of the tire, often peeling away in a single violent strip. This event, terrifying in any vehicle, was lethal in the Explorer due to the chassis architecture. As previously noted, while the suspension had been lowered, the engine placement remained high to save manufacturing costs. This meant the vehicle had a high center of gravity. When a rear tire failed at 70 miles per hour, the driver's natural reaction was to brake and steer away from the noise. The sudden shift in momentum, combined with the high center of mass and the soft suspension, caused the vehicle to trip over itself. The tank did not protect its occupants. It turned on them. But how many people were hurt? And what did Ford do when they realized what was happening? The aftermath was a cultural pivot point. The Explorer, once the darling of the suburbs and the symbol of safety, became a pariah. U-Haul famously banned the vehicle from renting trailers, a ban that persisted for years. The crisis shattered the illusion of the safe suburban tank. It revealed that the pursuit of isolation had compromised mechanical safety. The industry realized that you could not force a body-on-frame truck to behave like a sports sedan without consequences. This disaster effectively ended the golden age of the truck-based family, SUV, and it forced manufacturers to accelerate the development of unibody crossovers. It also marked the beginning of the end for the second-generation platform, which would spend its final years being quietly stripped of the very luxury features that had made it a legend. As the 1990s drew to a close, the Explorer entered its twilight years. The Firestone crisis had damaged the public perception of the brand, but the internal erosion of the platform had already begun inside the factory. From 1999 to 2001, the vehicle underwent a process known in the industry as decontenting. This is the quiet, gradual removal of features to increase profit margins, a slow fade into cost-optimized mediocrity. But as the crisis unfolded, something else was happening inside the factory. Ford was not doubling down on quality, it was doing the opposite. The first casualties were the lights. The early models featured a dedicated utility lamp under the hood, a mercury switch light in the engine bay, and a light inside the glove box. By the end of production in 2001, these circuits were removed. The engine bay and storage compartments were left in darkness. The deep pile carpet that once mimicked a living room rug was replaced with a thinner, more synthetic loop that felt harsh to the touch. The convincing wood veneers of the limited trim were swapped for appliques that were unapologetically plastic, shiny, and hollow. The changes went deeper than just the trim. The mechanical soul of the machine began to simplify in ways that alienated the enthusiast. The robust fuel systems of the early models were replaced by a returnless setup. While this prioritized manufacturing ease and emissions compliance, it sacrificed tunability. It was a signal that the era of the mechanic was ending and the era of the appliance was beginning. This shift is most visible when comparing the second generation to its modern successors. The UN-105 was built with a cast iron block and a steel body on a heavy steel frame. It absorbed vibration through sheer mass. Today, the Explorer is largely an aluminum unibody construction. It is lighter, faster, and more efficient, but it lacks the dampening qualities of heavy metal. Modern engineers solve noise with active noise cancellation speakers that play anti-noise frequencies, rather than using expensive laminate steel to stop the sound at the source. The automotive world has moved from a philosophy of repair to a philosophy of disposal. The second-generation Explorer had a transmission dipstick. It had grease fittings on the chassis. It was designed to be maintained indefinitely by someone with a wrench. Modern equivalents feature sealed transmissions filled for life, a phrase that usually means the life of the warranty. When a component fails today, it is not fixed. It is replaced as a modular unit. The tactile experience has evaporated. In 1995, the throttle was a physical steel cable connecting the foot of the driver to the engine intake. When the pedal was pressed, the driver felt the mechanical resistance of the return spring. They were physically opening the lungs of the engine. Today, the pedal is merely a sensor sending a digital request to a computer, which decides how much power the driver is allowed to have based on traction algorithms and fuel economy targets. The mechanical connection is gone, and with it a direct line to the feel of the vehicle. There is a distinct lag, a digital hesitation that serves as a reminder that the human is no longer in charge. The heavy double-sided steel key has been replaced by a plastic fob. The satisfying click of a physical button has been replaced by the smudge of a capacitive touchscreen. The sensory feedback loop between man and machine has been severed, leaving the driver with transportation that is objectively better but subjectively empty. Looking back, the second-generation Explorer stands as a singular moment in automotive history. It was the zenith of the suburban tank era. It was imperfect, heavy, and undeniably thirsty, but it was built with a substance that modern manufacturing can no longer afford to replicate. There is a profound irony in its legacy. The very quest for luxury that defined it, the desire to make a truck float like a cloud, was ultimately what tarnished its reputation. It tried too hard to be something it was not. Yet, for those who understand it, the UN-105 remains a monument to American ambition. It invites the enthusiast to appreciate the weight, the smell of real leather, and the intentionality of the machine before such things disappear entirely from the road.